Okay, so thanks for joining, guys. Today I want to do Leetcode 49 called Group Anagrams Together. So, given an array of strings, group the anagrams together. You can return the answer in any order. Okay, so an anagram is a word or a phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters at once. So, for example, here we have the letter eat. Eat is an anagram of T. I'm making it big. So eat is an anagram of T because when you rearrange the letters, they basically are the same, right? So we have one E, we have one E, one A, one T, and here we also have one T, one A, and one A. So if you make like a dictionary, like E, we have one, then we have A, we have one, and then we have a T, also have one. So these two are anagrams of each other. Now what we need to do is we need to group these together and return them as we find them. So one strategy that you should know for anagrams is basically two things. So the first thing is that a word is an anagram of each other when the frequency of the letters is the same. So this is what I illustrated here already. So eat is an anagram of T because the frequencies of the letters are the same. That's kind of the most general way you have to look at anagrams. Another way of looking at anagrams, which is actually the simpler one, which is the one we're going to use here, is that a word is an anagram of each other if you can sort it and it becomes the same. So if we sort EAT in alphabetical order, we get A, E, T. And if we sort T in alphabetical order, we get the same. We get A, E, T. So similarly, that when two anagrams are the same, when the word frequencies are the same, this is the most pure definition. We can just also say, oh, let's sort them both and then see whether the sorted versions are the same. So that's actually the strategy that we are going to use to solve this problem. And then I'm going to explain how you can use this one, but I personally wasn't able to get it working. So what we're going to do is we are going to look for each word that we get here. We are going to make a hash map, and for the key, we are going to use the sorted version of the word. So the first one would be we would store as AET. So we would get we will create a hash map. We will create a hash map, and the first key is gonna be AET, and then we are gonna append ETH to there. The second word is gonna be the sorted version, which is AET. Oh, but we already have that, so we can append T here. And the third one, the key is going to be the sorted version, which is tan, so it's going to be A and T. We're going to append tan to there. So that's what we're going to do. And then if you build up the solution in this way, what you see is that all you have to do at the end is just return all the values from the dict. All right, so let's code that up and see whether it works. So first we need a default dict, right? So from, I'm going to zoom in a bit. From collections import default dict. And then we said we are going to use the sorted key, the sorted string as the value. So let's do that. So we go for s in strs. So we iterate over all the possible values. We say that the key should be the sorted value of s. Now I like to work iteratively, so I run it now. Oh, I should also make default dict. So we say d equals default dict. And we're gonna use the callable, the default value as a list, so we can append to it. And now we see that the key is actually a list, so it returns it as a list. So we need to append that together. So we say join. And now we're going to, so for EAT, the key is going to be EAT. For T, the key is going to be AET. And then we're going to append those to the default dict. So we say D, the key, append S. So now make sure you don't like return it, because appending returns none. So that's a mistake that's often made. So let's see what the dict is like then at the end. We have a default dict. Yeah, so now see, we have the key is A and T, and we have tan and nat in there. And so this is going to be one group, bat is going to be one group, and eat, t, and eight is also going to be one group. So all that we have to do now is return the values of the dict appended to each other. Well, appended in a list comprehension. So we say return value for key value in the items, and that should be it. Run code. Nice. Now we submit it. I forgot to mention that the time complexity of this, because we have to sort every string, I think it's O of log n log n. I have to check my notes for this. It's O n log n. But because we have to do that m times, because we have m strings, it's actually m times n log n. So it's fairly quick. Uses a bit of memory. So this is one solution. There is another solution which might actually be faster, but I personally wasn't able to get it to work. And what you need to do is, here we use a very smart way of sorting the string. But what you can also do is you can make a frequency of the counts, right? That's what we said in the beginning. Either you sort them and use that as like as a key. But what you can also do is you can make a count of all the frequencies of the letters and use that as a key. I tried it. I wasn't really able to get it to work, and this one did work. Okay, so how do we remember this stuff? To remember things, I like to use flashcards. So I have a deck which we call Leetcode, and there I usually add like I add the question and the solution to it, so we can use space repetition to quiz ourselves, basically. So let's add a card. So we say, okay, what is the solution to, and then I made a screenshot to this one. The solution is to use the sorted string as a key, and then append the value. So use sorted string as key. That's actually everything you need to remember. Nice. And then, of course, you add the cards, but you should also still study them. So let's study them together. So this is one I made earlier, which is called invert a binary tree. And how do we invert a binary tree? Now I have to think again. So this is a recursion problem. If you are at the base node, you don't have to return anything. And if you are not at the base node, then you need to swap the two. You need to swap the left node and the right node. And then once you've swapped the left node and the right node, you also need to call this recursively on the left node and the right node. Yeah, so if the base case, you swap them and then you recurse. Same story, so you have the base case, then you don't return anything. And if you're not at the base case, you need to go to the node, swap left and right, and then call it recursively on the left and the right tree. Okay, group anagrams. So how do we solve this problem with the anagrams? You need to remember that you have an anagram when you have either the same frequency, so you make like a frequency map of each word, or a simpler way and more Pythonic way, in my opinion, is to use the sorted value is to use a sorted string as a key in a dictionary and then append it there. So we use the sorted string as the key. And then again, how do we solve this group anagram problems? We just use the sorted string as a key. Thanks for watching. I hope you found it useful, and see you next time.